Welcome to the Explainer. If you're gearing up for your IGCSE Computer Science exams, you know that input devices are a huge deal. Today, we're going to jump right in and break down how a computer can actually see an image or hear a sound. You know, how it translates our world into its digital language.
So, here's what we've got on tap. We'll kick things off with the basic problem, how computers even sense things. Then we'll introduce the magic little component that makes it all work. We'll see it in action with cameras and microphones, and then wrap up by looking at the pros and cons of it all.
Okay, let's get into it. Before we can understand how any of this works, we really have to start with a pretty fundamental question. It gets right to the heart of what computing is all about.
I mean, really think about that for a second. The world we experience is just filled with light, color, sound. It's messy and complex. But a computer, all it understands is binary, ones and zeros. So this is the main challenge, right? How in the world do you bridge that massive gap?
See, our world is what we call analog. The sound of a voice isn't a bunch of separate points, it's a smooth, continuous wave. The light making up a sunset is an infinite spectrum of colors. But computers, they're digital. They need everything broken down into neat, separate, bite-sized chunks, those ones and zeros they can actually work with.
So there's this huge divide. To make any sense of our world, a computer absolutely needs a translator. Something that can take all that smooth, analog stuff and convert it into the discrete, digital code that it understands.
So how does this translation actually happen? Well, it's time to meet the component that makes this all possible. You could call it the unsung hero of all digital input.
And here it is, the Analog-to-Digital Converter, or as we'll call it, the ADC. This is the crucial bit of kit. It's a tiny electronic circuit that acts as the perfect interpreter between our reality and the computer's digital brain.
So how does this ADC pull off its magic trick? Well, it's basically a super fast three-step process. First, it samples the analog wave. Think of it like taking thousands of tiny snapshots of it every single second. Then it quantizes each of those snapshots, which is just a fancy way of saying it gives each one a specific number. And finally, it encodes that number into binary. And there you have it, the ones and zeros the computer can finally understand. All right, let's see this amazing translator in action. First up, let's look at how a digital camera uses an ADC to literally see the world.
So, when you snap a photo, light from whatever you're looking at floods through the lens and hits an image sensor. This sensor is just a grid of millions of tiny dots called pixels. Each one of those pixels measures the analog light hitting it. And this is where our hero, the ADC, jumps in. It takes the light reading from every single pixel and converts it into a binary number. All those numbers together, that's your digital picture.
And this process gives us some amazing benefits, right? We get instant photos we can see right away, we can copy them a million times, and we can edit them with software. But there's always a trade-off. The cameras themselves can be pretty complex. And most importantly, the quality of your photo is only as good as its weakest link. It all comes down to the quality of that sensor and, you guessed it, the precision of that analog-to-digital converter.
Fantastic. So we've covered how a computer sees. Now let's switch gears and explore how it hears the world using a microphone. A microphone actually works in a really similar way. Analog sound waves in the air hit a tiny little part inside called the diaphragm and make it vibrate. Those vibrations get turned into a continuous analog electrical signal that's a perfect copy of the original sound. And then what happens? The ADC takes that signal, samples it thousands of times a second, and turns each sample into a binary value. That stream of values becomes your digital audio file.
And again, the trade-offs here are pretty clear. We get this incredible power to capture sound, save it, and use it for, well, everything from phone calls to recording a hit song. But on the other hand, cheaper mics can pick up a ton of background noise, and the really good ones often need to be carefully calibrated to get an accurate sound.
Okay, let's zoom out for a second and just put all this in a bigger context. Let's talk about the basic job of all input devices.
This quote from Geeks for Geeks just nails it, doesn't it? It doesn't matter if it's a camera, a mic, a keyboard, or a scanner. The job of an input device is always the same: to be that crucial translator between our world and the computers.
So, as you're studying for your IGCSE exam, if you take one single thing away from this explainer, let it be this. The analog-to-digital converter is the key. The ADC is the MVP. It's the fundamental piece of technology that lets a digital computer process all that messy, analog information like light and sound from the world around us. And that kind of leaves us with one final thought. The tech behind these ADCs is getting better and better, faster and more accurate every year. We've pretty much nailed digital sight and sound. So looking ahead, what human sense do you think computers will conquer next? Touch? Maybe smell or taste? The possibilities are really fascinating to think about.